We will move on with the program. Now we will hear from the end users how they see a roadmap for their specific applications. And we will start with Cedric VERHAEGHE from DAMEN.
Thank you, Tatiana. So I will present the roadmap for DAMEN Naval. After me, the roadmap from offshore by Parkwind and also maritime by BAE Systems will also be presented. So, very short introduction about DAMEN. DAMEN is a shipbuilder that's active in many different fields, such as offshore, ferry transport, and also naval sector, in which I am involved. We have about 150 to 180 new builds per year, and we make those ships in steel, aluminium, and composites. What we do with adhesives for DAMEN Naval, as for big ships, is typically the small, low-risk applications, which we can do without the need for certification. For this, we did some small testing, and then we standardized it, and then we can apply it based on those standards. We want, of course, to expand on that, said this morning. And what we want to do is the end goal is to have a composite superstructure on a steel hull. Why we want to do this is because the weight of the composite superstructure reduces the weight on top of the ship, thus lowers the stability point of the ship, which can either cause increased functionality, so more systems on top of the ship, can automatically will reduce the weight, and because of the lower stability point, your beam can be made slender, more slender, and the propulsion can be optimized. So by doing this, we are hoping to initiate a design cycle, a positive design cycle, that one effect results into the other and combines into a greater effect than the separate parts. So that's why we joined into the Qualify project, because the hybrid joint in the primary structure is a novel structure for us. We typically weld the primary structure completely. We have only one-off designs. We have maintenance every 5 years. So we have to do the thorough investigation before we start constructing. We cannot make a test ship. So the ambition at the start of the project was to reduce the risk of the application for this joint and to go towards certification of the adhesive bond. So, as you already saw today, the Qualify scope includes quite a lot of different aspects. I think most technical aspects are covered within the yellow circle, which is the Qualify scope, but there are some stuff still lacking for certification and application, and that's the naval loads, which are not included into the scope, fire safety, which was excluded from the scope, which is a separate study on its own, and then the final certification, which cannot be given in a research project. And then once we have the standard, the certification, we would also need to follow that up with standardization of the joint, and then finally to go for application. And then result into classification, guidelines, and rules. So I'm not going to discuss the naval loads because that's too confidential to share. The fire safety is something we have been looking at in a lot of research projects in the past already. We did quite some tests with Delight and Best, where we did a full-scale fire test on a composite structure that was also joined with a similar joint to the Qualify joint. And recently we've worked to develop guidelines for the risk-based design approval of fire safety designs in Ramses And parallel, the classification societies worked on fibership to do the same thing, and that's all part of the Horizon 2020 project. One of the results of this project was the validation of the interim guidelines, or at least the proposal for the validation of the interim guidelines for the application of composite structures on ship. So, yeah, for us that's covered. The second part, the certification aspect, is also a task we need to do quite soon, is together with Bureau Veritas and Lloyds to see if we can translate all the items within the yellow scope to actual certification. So that would mean to discuss with Bureau Veritas and Lloyds approval responsibles, so the appraisal of Lloyds and Bureau Veritas, to see what are the requirements, performance evaluation of our specific joint for our specific project, and if we can get that approval. From what I learned is that it should be a checklist at this point, but still it's something we need to document for the next step. The next step then would be to, if we have a way of getting approval, is to standardize the production method and the inspection and monitoring plan of the joint. And then the following step would be to prepare for future development. So to see if we would modify something in the future, maybe something in geometry or materials, both composite steel or the adhesive, is to develop a test methodology for adhesive systems and joint designs. And the same for the design and documentation of the methodology for similar adhesive systems and joint development, such that we don't have to restart the whole project for every difference, but that we can use the results and see what aspects are affected by this change, and then quickly be able to innovate on this. And then the next thing is to use these tools for design improvement of the joint, and then following that is to develop monitoring systems and digital twins to also measure the actual performance of the joint during its lifetime. The last step is the application, and as you heard this morning, we are planning to apply it quite soon. So the ambition is to apply it by 2023, and that would allow us to directly implement these standards and the methodologies we've developed within Qualify and afterwards, and build on the experience of actually building it. If we also add the in-service monitoring, we can also learn more on the actual loading and damage of a joint. So translate real loads to what we have simulated, and then we could implement that further in future surface combatants. And after that, that's the future, is to further develop this joint with the eye on recyclability and life cycle analysis. So removable joints and using natural polymers for adhesive to develop also a more environmental friendly and safe production method. So this is part of the DAMEN sustainability goals. To summarize, I've made here the roadmap. So the green parts are what is already been done. The orange parts are in progress, and then the red parts are still to be started. So on the top you see the application, so the vision. So we are already able to apply small and secondary structures that are not certified. For that, we, like I said, we did the standardization and we started the application. And in the past, we did analytical design. With Qualify, we improved the knowledge on FE modeling, on durability, and on production strategy, and also on the effect that production strategy has on the performance of a joint, such as voids and damage. We've developed the fire safety within the other project. The inspection and maintenance strategy has been developed in Qualify, but I think we need to further develop that to get an actual standard. And once we have these R&D items, we can start with the certification and standardization, and then finally application of primary structures. And then for the future, we would start in parallel the research projects on digital twins, test and design methodology, and the life cycle analysis. So that was my presentation on the DAMEN naval roadmap for adhesively bonded hybrid structures. So if there are any questions, I'm happy to respond.
Thank you very much, Cedric. That was really nice. Questions from the floor or online? Online, no? From the floor? Okay, I have a question. You said something very interesting about removable joints. So in Qualify, we did a lot of work on this MMA adhesive, and now we know that it performs very well, and it seems like the right adhesive for primary structures. But how do you see, well, maybe our observer partners from Cedric, they're online and would like to comment on what would be the sustainability of this adhesive, and then how do you see the transition towards these removable joints using sustainable adhesives, because I'm not sure what options are out there at the moment.
So should we have the word first for Zagreb? Or?
If we have somebody online from Zagreb.
We have someone live from Zagreb.
Yes. Would you like to come up? But, you know, from a, yeah.
Well, one very simple option is to heat it up, that it is softening, the material is softening, and then you can demolute it.
But, okay, but the sustainable, so is this what you mean by sustainable, or do you more like recyclable?
But this is not a point where we already have investigated a lot in. When I think of restrainable, I think of being able to remove the joint and replace the adhesive, which would be tricky with the current set of adhesives we use. But at the moment, it still conflicts with the other requirements we still have for the joint. So I think even for removable joints, we still need to demonstrate the strength when it's not supposed to be removed. So still the fatigue, all the aspects we covered within Qualify should also be respected for the removable joint. So I don't have a system yet in mind.
Yeah, I know, but like I have knowledge in adhesives. I know that this is not going to be something so straightforward unless you start developing one that is environmentally friendly or sustainable.
Version 2.2.
Yeah, version 2.2. Exactly. Okay, thank you. Do we have more questions? No? Okay. No? Okay. Thank you very much, Cedric.